Welcome back, everyone. Welcome to today's practice talk session. We are very happy to welcome back a speaker from last year's process mining camp, Sudhendu from AIG. Welcome, Sudhendu. It's really great to have you here again today.
Thank you.
So, Sudhendu, your talk will be about combining process mining with simulation. And I know you have been working with process mining for a few years now, but you have been working with simulation much longer already. Is this correct?
Yes. So what I'll be talking to you about today is, as you said, how simulation and process mining can be together deployed in improving and optimizing service operations. And as you see in the title of my talk, there is a framework called Process Wind Tunnel, which I'll be discussing as part of my presentation.
All right, that's great. I know many people are interested about process mining and simulation. I personally get asked about it all the time. So we're really looking forward to your presentation. Please take it away.
Okay, thank you, Anne. Hello, everyone. As Anne said, my name is Sudhendu and I work in AIG. For many of you might know, AIG is a very large insurance company. And what I am focused on is the problem of, understanding and improving and optimizing business processes. So what I will discuss today is a case study on how we have improved and optimized a service operation. If many of you who may have been at last year's camp, I talked about how we improved our insurance underwriting process, which is more on the front end side, and the service operation is more on the back end, when we are servicing our clients. So what I will, my talk will have actually two parts. Even though the case study applies to the same service operation, the first part will talk about how we improved and optimized it. And as you heard Anne talk about simulation and process mining, so I'll show how process mining is embedded in this broader framework called Process Wind Tunnel, and which we use for improving and optimizing processes. And then the second part will be focused on purely process mining, how you can just use the data from service operations and utilize process mining to gain insights. And some of these insights can then drive you to further improvement. So as I said, just giving you some context that, you'll hear two components of the talk. So what is process wind tunnel and why we call it a wind tunnel? I mean, many of you know that wind tunnels are used to design race cars and aircrafts. The idea is that you build a model of these cars and aeroplanes before you actually send it to final production. And so this is metaphorical, and that's why we are calling it process wind tunnel. We want to build a similar environment where we can test drive our process, do a lot of what ifs, understand what's the best way to design the structure and the parameters of the process, and then actually put it in action. And really we have 4 phases, and this is a very data-driven approach. So the first phase is, if it's an existing process, we like to collect a lot of data from the process. So one is more of the traditional process map, business rules. We will do an extensive process mapping. Sometimes the process map might exist. We might have to understand, how is the process supposed to work. Then typically in today's world, especially in insurance and finance, a lot of these processes are orchestrated by IT applications and business systems, which are collecting data. And so you have an exhaustive trove of data coming from all these different business applications. And we can work with the IT teams to extract all that data. There are some challenges, of course. Many times, the data may come from different systems, and each system might use its own way of representing the data. So there is a data dictionary, if you might want to call, for each of these systems. And then when you bring it all together to get an end-to-end view, you have to fuse the data together. Sometimes you have to clean it and then put all of the data together so you get an end-to-end view of the process. And then there are some more static operational issues. If there are people working there, what's the nature of the facility, how many people are there, what their skills are, what their hours of operation are, and the like. So that's a fairly extensive data collection effort that precedes the analysis and optimization work, and we broadly just call it data collection phase. Once we have the data, then, as I said, the intent is to get insights into what's going on in the process. So there's a lot of data wrangling that happens, which means you are slicing and dicing the data, joining data, and then using statistical analysis tools. We like to explore what is in the data. And of course, that's where process mining plays a very important role, because with its focus on process discovery and conformance, you can actually utilize this technology to get deeper process insights. What's the structure of the process? Where are the bottlenecks? How does the process, how is the workflow through the different paths in the process, so to speak? So the process mining is again used to discover a lot of insights. At the same time, by linking it with these statistical analysis tools, you can actually get a lot of stratified information on what's going on in the operations or in the service process. Because typically these service processes are not just handling one customer, for example, or one type of work. There could be multiple customers, multiple types of work flowing through the system. And by working with the filtering, for example, the filtering capability of process mining, and then exporting all that data to these statistical analysis tools, and sometimes just doing descriptive statistics on these subsets, you can get a lot of insights. In addition, one can also utilize more predictive analytics capabilities. For example, you may have many different kinds of customers, but there are maybe certain kinds of service requests combined with the customer that may be creating bottlenecks in the system. Or certain customer and service requests might be flowing very efficiently. We like to call that, for example, the happy path, right? And by using some of these predictive analytics tools, we are able to essentially get those insights on what these clusters are, and then you can work on them accordingly. So this phase, what we call the current state analysis, at the end of it, we have a fairly good insight into what is going on in the process. Then we use that to figure out how do we develop the future state. How do we improve the process? And that's where, so far we have been looking at the historical data, seeing how things have been happening. And the next phase is, how do we improve the process? And that's where this simulation comes into play. And we use discrete event simulation. And the thing is, it's all driven by the data. And in particular, a lot of the components of this discrete event simulation model come from process mining. So, for example, when you do a discrete event simulation, you want to know what are the critical steps. I mean, that insight can be obtained from process mining. You want to know what percentage of work flows through what part of the model. That you can get from the process mining tools. You can also get the distribution of the various activities. How much time does it take to perform a specific task? And these are all important components that you have to put into the simulation model. And the data that you have collected, combined with process mining and some of the statistical analysis you have done, can feed these simulation models. And once you have the model built, you have to tune it to make sure that the model output matches what the reality is. And then now you have your wind tunnel, which you can then use to do a lot of what-if analysis, scenario analysis, to improve and optimize the process. And then if the changes that you come up with or the insights you gain to make the changes make a lot of sense, then we run some pilots and maybe develop some tools, maybe make some system changes. In many cases, some change management exercises might be required, and then we deploy the solution. So that's kind of the framework of process wind tunnel. And as you heard earlier, and said, there are really two major components, process mining and simulation, that helps you achieve these improvements. So what I'll be talking about is how we utilize that to improve one of our service operations. So just to give you a background, this service operation is actually consists of two. It has an onshore footprint and an offshore footprint, and together they are processing customer service requests. And the input that this operation gets is both paper and digital. So some of the requests come through physical mail, overnight mail, USPS mail, And some of it might come through faxes, digital faxes, or emails. And that's how the request is received. Then there's a team that processes all these customer requests, and the stuff that is in paper form is digitized through a scanning operation. And then once it's digitized, then it is further, it goes through a process called indexing, where we are extracting certain information from these scanned images or annotating these scanned images, and then sending it down to the processors who will then process the customer service request. So the first phase I'll be talking about is this operation that receives the input, scans it, indexes it, and then sends it over to the other operation for actual processing. So just to give you a size, this operation is processing about 16,000 documents a month. As I said, the input is in multiple formats. So there are 2 site locations. And so this is kind of the high-level view of of the nature of the operation where we use process wind tunnel. Now moving to the actual data collection step. When stuff arrives in paper form, like mail and stuff, you typically don't have event data at that granular level that you might get if the request is coming digitally. So there was some manual data collection that was required. As I said, when the stuff comes in, the mail is sorted, overnight mail is logged. There's some prepping work done where different types of mails are grouped together to create common clusters. And all of this was happening without the help of an IT system, maybe except for, let's say, the logging piece. So we manually did some time and motion studies to capture the parameters for this part of the process. Now, once the document has been scanned and it goes into a digital format, from that point onwards, the underlying business application is capturing a lot of the event data and other attribute data. So the data suddenly quality becomes very rich once the document goes into a digital form. So we had a mixture of 2 types of data. One was the manual data, and the other one was the IT data. Now, once we had the data, as I said, we had to fuse the data. As I said, the data was at different levels of granularity, so we had to clean the data, maybe estimate some things which, let's say, were missing or were not very clear. All that exercise I broadly call data wrangling. And then once we have put all the data together, we have now a good view of the process, a data-driven view of the process. A lot of descriptive statistics can be done on that data, which starts giving you insights into, what's the mix of the work that's coming in, how does the volume fluctuate over the day of the week, how does it fluctuate over time of the day, and that starts giving you some insights into, how the queues are building up. Now, as I said, this data set that I was referring to is really trying to analyze the first part of the process before the information is sent over to the processors. So the key here is how quickly can we send the information to the processor. So let's say the mail arrives in the morning, and if you send it to the downstream processors at, let's say, 3 p.m. or 4 p.m., they hardly have any time to process the request that day. So by default, a lot of the work will roll over to the next day, and the customer won't get his or her request processed until, let's say, the next day. However, if we can speed up the upstream process and send the stuff sooner, then maybe they'll have, let's say by noon, they'll have a lot more time to process the information. And maybe they can process a big chunk of the information the same day. So the critical aspect was how can we shrink the cycle time on this process and make sure that the processors get good quality data faster. So once we had established the baseline and saw exactly how the process was working, at a very detailed level, we then went ahead and built a simulation model. And the simulation model had, all these different steps: the sorting, prepping, indexing, what fraction goes into what path, and the parameters for all of those components in the simulation model were derived from, let's say, the process mining of the data. So all the distributions and the transition probabilities and things of that nature came from the data analysis and process mining. And then we we tuned the model output. Now, when I say I tune the model output, what do I mean? I mean, when you build a simulation model with all these, even a data-driven simulation model, may not match what you're seeing in the actual data. So let's say you want to, you're seeing that 80% of the work gets done by 3 p.m. I'm making a hypothetical case. And when you run the model, you might see that your model says that the 80% of the work gets done by 1 o'clock. So there's something missing in your model, right? So you have to go and figure out, what is that? I mean, it could be that the way you model the breaks that the operators are taking is not correct, or maybe you didn't model the way the sorting to the prepping transition was happening. So there is kind of going back and forth between the data and the model until you get it right. Now, when I say you get it right, we are dealing with distributions in simulation, statistical distributions. So getting it right means you have to match the distributions. And of course, these are complex distributions, so sometimes you may have to match it. There could be multiple moments of this distribution, like the mean is one, standard deviation is another. There could be other higher moments. So we typically like to match the mean and the standard deviation. And by working with the operations, we are able to get to a point where the model output matches what the data is saying. Now, once we have that, then we have a good test bed to try out what-if scenarios. And you could be looking at a variety of things. Things like, you could change the time, for example, at which operators show up. You might want to change the batches in which they are working. So, and there could be different kinds of batches, right? There's a notion of process batch. So if they are taking stuff, prepping it, moving it, what's the process batch? Or what is the batch in which they are moving stuff? And all these things have a direct impact on the operation. As you can imagine, if you have a small batch process, you have a lot of movement happening in the operation. If you have too much of a big batch, then things are waiting between processes and queues are getting built up. So there is opportunity to optimize some of these parameters, and you don't have to go in physically and try out these things, which can be very disruptive. You can do it in the model, and then by doing that, we can see what strategies make the most sense, which is giving us the best improvement. Now, when you are trying to improve the process, you're not just trying to improve the mean, which of course is important, but you also want to look at the tail of the distribution. Things that were taking too long. Are we fixing that problem, or is it just fixing the mean, and then maybe some of the stuff that was taking too long still are taking too long, because those are the ones that cause customer dissatisfaction. So that's what we did here, and I was giving you some insights, and we finally came up with some insights on what to change and how to optimize the process that would result in almost 50% improvement in the cycle time from the point a request is received to the point it's sent over to the processors. And that was a big surprise. I mean, as you know, when you go into an operation, there's always some opportunity to improve something. But when you see 50%, that's like, that means, you've really uncovered some major insights. And this does not mean that the operation was not doing things properly. It was such a complex interaction between the various things that were going on that by applying this approach, it became very transparent, and the model then started giving us insights into what to improve. So once we presented this, the next step was we have to validate it. It's one thing that the model says 50% improvement, but will it bear out in real world environment? And so we ran a pilot for a little over 2 months, maybe longer. So as you can see, on the right side, I'm showing you some of the numbers that we saw in terms of improvement. So we did this project, and let's say we used April as our baseline. And what we were seeing is the average turnaround time was 6.5 hours. And the 90th percentile for the turnaround time distribution means 90% of the stuff was less than 9 hours. So that was what the baseline was saying. And then when we did the model, we thought you could actually do it in 2.8 hours, and the 90%, the 90th percentile of the distribution would be 6 hours. So that was what we had. We were sort of hoping to achieve. And when we ran the pilot, you can see the numbers the average was actually quite close. And in fact, the 90th percentile TAT was even better than what we were expecting. And this happened while the volumes, which you can see below in the September-October timeframe, actually the monthly volumes had actually gone up by over 20%. So even with the increase in volume, or 30%, even with the increase in volume, we were able to significantly reduce the cycle time. And once we did that, we could go back to the same process, collect the same data, perform the same type of analysis on the final, look at the process mine the data, and see how did the futures or the improved state, how did it compare to what we originally measured. So it's very objective. And these numbers give you, I mean, it's hard to dispute because you're working with numbers and data, and a lot of the data that we have collected actually comes from computer-based systems, which mean they're being automatically collected. So there's a lot of inherent power to this methodology. I think in one of the earlier talks, people talked about how process mining can give you that objectivity and also help with change management, because once you are presenting data, it's easier to get people's buy-in because it's hard to dispute that. So that was an example of how we used process mining in conjunction with simulation and statistical analysis and some of the other things I mentioned to improve a real-world process. And as I said, we actually not only did we model it, we actually implemented it, piloted it, and we saw the improvements realized in the real-world process. What I want to do in the next part of my talk is move on to the downstream operation. So once all the data has been extracted from these customer requests and digitized, indexed, now the processors will get that and then start processing the customer request. So similar to the previous operation of the upstream operation, we had an onshore and an offshore team. Similarly, the downstream operation had an offshore team and an onshore team and an offshore team. So what we were a bit lucky when we moved to the downstream operation. Everything was digital and was being done largely on computers. So a lot of the data, event data, which is really critical to do process mining, was being captured. And the application that was being used was a homegrown application. And we were kind of concerned that, are we going to get the data we need to do these kinds of analysis? And luckily, the underlying system that was being used was capturing a lot of the event data. So what we did was, we working with the IT team, we were able to get the data. We were able to understand, what the data means, because the event data just tells you, when things are happening, but there are a lot of attributes of each event that you have to understand. And this was a very complex operation, doing many different kind of service, processing many different kind of service requests. So we had to really understand, how all these event data tied to the different attributes of the service requests. Once we had done that, we were able to utilize process mining to gain insights into what was going on in the operation. So I won't go through a whole lot. My intent here is to show you how process mining by itself, if the data exists, you can actually get tremendous insights into what is going on in the process. And a lot of times, just getting those insights can help you even improve the process, at least make many different kinds of improvements. So I will talk about 4 or 5 different insights we got, which is a subset of the entire work, but it should give you a flavor of how we were able to utilize this technology. So one of the things I'll talk about is process variants, and I have different slides on each of them. So I'm just going to quickly go through. The other one was how work was being done. What was the impact of handoffs, both from the onshore to the offshore team as well as within the site, as well as as I said, work is coming from an upstream operation. So are there any kind of delays that were happening as a result of the handoff between the upstream and the downstream operation? So broadly speaking, there are the impact of handoffs, the impact of a large number of process variants, as well as how work was being processed. Was it push or pull? So let me go through them one by one. And some rework ideas also. So one of the things we found is when we looked at the data, we found that there were a lot of process variants. In fact, just within the onshore operations, we saw 255 process variants, whereas the offshore had even more, 646 process variants. So what it's telling us is that as people are processing these requests, there is a lot of flexibility in what they do and how they do it. So while there is nothing there's nothing wrong, because the end goal is to get the work done. But I think the insight here was, can we look at all these variants and figure out, why people are doing things slightly differently? There may be 10 steps. I might decide to start with step number 4, go to step number 3, and so on and so forth. Somebody else might do it a little bit differently. And of course, when you run, let's say, the process mining tool, it also tells you which variants are more dominant, which ones are more rare, and both give you insights. The more dominant ones tells you, something that, most people are doing the same way. If there are those rare ones, you can actually look at them and say, why did somebody do things a bit differently? And that itself starts giving you insights into how people are reacting, because a lot of times people are reacting to other things that are happening around them. And that gets captured, and with process mining, you can get much more deeper insights. The next one example I want to touch base on was how work is being assigned and processed. So one of the things we found is that the onshore team was using a pull model. Pull means that all the work that comes in goes into, quote unquote, a basket, and then they're using a push model. I misspoke. The onshore team was using a push model. So stuff goes into a basket, and from that point onwards, it gets assigned to the different processors. And when we looked at the data, as you can see, through the process mining, we were able to see that. And then we can also look and see, what is the impact on the various time delays as a result of using a push model. Same thing if you go to the offshore model, they were using a pull model where stuff would go into a basket, and then the operators or processors would be pulling from that basket based on certain rules and skills and so on and so forth. And then you can even look at that and say, okay, what is it that is, what is the impact of that? And you can see here, they have different time delays between different steps. And you can sort of trade off and say, okay, in which case is the pull model working? In which case is the push model working, and why? So a lot of these questions you can actually answer by just looking at what was the impact of different strategies of processing the work. And you may even ask, why is somebody using pull and why is somebody using push? And we did ask those questions, and those questions gave us significant insights into why people were doing things the way they were doing, which is sometimes there's nothing wrong, but sometimes those things are implicit, and when you and the data starts helping you evaluate the impact of those decisions. The next one, for example, was the handoff from offshore to onshore. So when the data came from the upstream operation, by default, in this case, let's say it was going to the offshore team, and the offshore team would try and process it. If they couldn't process it for whatever reason, either it was too complex, it required some onshore effort, maybe some communication, there was some complexity, it was redirected to the onshore team. And then sometimes the onshore team might send stuff back to the offshore team with some clarification. So you can see all that in this extract from a process mining analysis. And it tells you, right, how much stuff is coming in, how much is being done by onshore, how much is being done by offshore, and then what is the corresponding impact on, let's say, turnaround time. So you can see, for example, that almost 20% of the work is going from offshore to onshore. So there's something that the offshore team is unable to process those 20% of the work. And what is the impact on, let's say, the turnaround time? I mean, the numbers are not that important, but the concept that you can actually analyze a process at this level of detail and get a very quantitative view of how these two teams are working and how work is flowing back and forth is pretty powerful. Then the third thing is, just like there is handoff happening between the onshore and offshore, similarly, there is handoff happening within each of these operations. So let's say I'm a processor in the onshore operation. I might pick up a request and I might say, I can't do this work. I may need to pass it on to somebody else for whatever reason. So there is some handoff happening, right, internally. And that is, again, what is the impact of that? You can see some of those can be pretty dramatic. So you can see, for example, in this case, without handoffs, on the average, things were getting done in 2.1 hours. But with handoffs, it was taking significantly much longer. And then you can see, what percentage of the work is happening with handoffs, what is happening without handoffs. And you start suddenly getting a lot of detailed information, which is, in the beginning, was pretty opaque. Nobody knew that this is the impact of each of these decisions that people are making, and that can help you with your 5 why analysis. You can go down, drill down, and try to find out how to even improve that. Again, as I mentioned, work is coming from upstream to downstream, so you can also see, okay, I'm speeding up my upstream operation. But let's say if I send it to downstream and there is some significant queuing delay between the time I release it from upstream and the downstream operation picks it, then I'm losing time, right? And again, with this data and with the process mining, we were able to actually quantify that. And then again, do for some root cause analysis and see, okay, is there a way we can improve or reduce that time? And the last one that I want to give is, what is the impact on the rework and the transfer queuing delay in the offshore and onshore operation. So anytime, let's say, I pick up something and I lock it and I start working on it, and then I abandon it for whatever reason, and I put it back in the original queue. How much impact is it having on the overall cycle time? And what percentage of the work is going through that process? And there could be many reasons, right? I mean, I may pick up a request, and I might find that I'm not capable of processing it. Maybe I don't have the skills. Maybe there was some further information that is required. There could be a variety of reasons, and I may put it back into the original queue, and so that somebody else could pick it up, or I may have to wait till the additional information becomes available. Now, what is the quantitative impact of that on the cycle time? Because that's what we want to improve here. We want to make the customer service experience outstanding for our clients. We want to reduce that time. And here, for example, what we found is that anytime something was being put back into the queue, we were losing on the average 6.5 hours, right? And we can also see what is the impact of that in an environment where people are using the assign approach, which is the push model, versus the pull model. So the intent of that here is that by looking at a lot of this data that exists, I mean, we didn't even have to go and create the data. The data already existed. What we did was, we processed the data, we understood what was being captured, and then we utilized process mining to gain these type of insights into the operation and bringing tremendous transparency into what was going on. And once things become transparent, a lot of times you can even just once you know what's not working properly, or even if it's working properly, knowing quantitatively what's going on, brings certain ideas on how you might want to change the process or improve the process. So that brings me to the conclusion of my talk. As I said earlier, I wanted to present two different views of process improvement. One where we looked at the end-to-end and we utilized the combination of process mining, simulation, statistical analysis and visualization, and actual implementation of the changes, and how we were able to realize significant cycle time improvements, even in the presence of increased volumes. And I don't think that's I've been doing this thing for many years now, is that it's not obvious when you walk into these operations that, that there may be some latent productivity, that if you took a very close, detailed, data-driven look into the processes, you might be able to come up with new solutions and more optimized workflows. So that was part one. And part two, as I said, if you're working in a purely digital environment where all the data exists, go look for it. I mean, sometimes, you may be surprised that how much data there already exists. And if you can find that data, in many cases, you could put it to good use through these technologies and get tremendous insights into what's going on. And at the same time, find out, how you can improve your operations. So with that, I think the opportunity to utilize either process mining independently or in the broader context of process improvement and optimization, as I talked about, I think there is a lot of opportunity to improve our business processes.
For showing these two cases. Thank you for showing both of these cases next to each other, right? So that has been really great to see, like this case where you combine process mining and simulation, and then one where you just applied process mining itself. I see that there are already some discussions going on in the Slack community. Please add your questions there, but I will also start by asking a few questions myself right now. So one thing I was wondering, I thought it was really telling when you were talking about the first case, right? So the first case where you said, well, you were surprised actually, and the team probably was surprised that there was such a big potential, right? That there were actually 50% potential of becoming that much faster, and what the reason for that is. It's not that they were doing anything wrong or that it was obvious, but it was actually not obvious because the process itself just is really complex, and this is the reality for many processes, that this complexity hides so much potential that there actually is, which you could then by your work make visible and actually tackle. What I'm wondering is, especially given the fact that there is this big complexity in those processes, I'm wondering, you talked about the simulation model and how you are actually, to get it right, you do need to do some tuning, right? So before you even start doing any kind of what-if analysis in the simulation tool, you have to get the baseline right, and the baseline needs to accurately reflect the current situation, because otherwise you're not having the right starting point for these what-if analysis where you're trying to change some parameters. So, and you said that this kind of tuning, basically trying to reflect reality, is what you did and what can be difficult. And I can imagine that it must be really complicated, actually, especially given the fact that these processes are so complex, right? That it's not obvious at all. So I'm curious, is there anything in your experience when you are tuning these simulation models to get them to reflect the as-is baseline, something that's particularly the problem, or where do you have to tune the most? Is it like the resources, or which kind of parameters? What are you tuning mostly when you're doing this?
So I don't think I can, we have done that in many instances. I don't think there is one sort of one answer I can give you for how best to tune. Let me give you an example of how we did it here, just to illustrate it. So one of the things we found is, and let me go back to the slide and just show you. Okay, so one of the things we found is, if you look at this volume profile, in this case we found that the work, the incoming work was the highest on a Monday, right? So typically Mondays were significantly higher volume compared to the rest of the week. And so when we were building the simulation model, we know that, let's say, people come in, they work, they take breaks, and so we put in, let's say, an hour for a break, right? And we ran the model, and we put an hour of break for both Monday, Tuesday, Wednesday, Thursday, Friday. It was a 5-day operation. We weren't getting exactly the right numbers and some of the right internal metrics from the simulation? Well, we found out that because Mondays were very, very busy, the breaks that these people were taking on Mondays were significantly shorter and in some cases staggered, because they just wanted to have all the resources working very, very busy. On the other days, because the volume, for example, you can see the third day of the week, the volume is very low. Now, it's very typical human behavior that when the volume is low, you can probably take a slightly longer break. So by changing, let's say, the break structure on the schedule, we were able to move the model output closer to what we were observing, right? Now, you might say that we could have gotten that right at the beginning, but sometimes when you're asking these questions from the operations, they may not actually. It's not that they're not giving you the information; it's just that they don't think it's important. But when you run the model, you might see that this is one of the things that does affect the behavior of, because sometimes the actual model behavior changes with the input. So this is just one example I gave you. There are similarly other knobs that you can use, and in other processes, for example, oftentimes there are decision points when you get to a certain point, and then work forks from that in a simulation model, and there is a transition probability I talked about, right? How much is going to each path? Mm-hmm. There is one you can look at statistical average, and in some cases you may want to stratify it further, because you might see that certain kinds of work have a different transition probability versus another. So you may start with a simple simulation model, but then if you see a gap between the output, you go and ask the next level of question and further stratify the simulation model, right? You put more data into the model until you get it right. So I'm just kind of trying to give you an approach on how we do this. It does depend on situation to situation, right? Because the process itself may be very different. But one has to be aware, it's an iterative approach. It takes maybe a few iterations before you get it right.
Mm. Yes, yeah, I can see what you're saying. So these are, I think, two good examples. And so one aspect relates to, from the examples you were giving, to human behavior, right? So that sometimes you need to, that's where a lot of complexity in the real world comes from, trying to, put the actual human behavior into the model on a sufficiently detailed level that you can make actual analysis based on that. But the other thing is that you start with maybe some kind of more of a summarized statistical input parameter, but then you realize you have to discriminate more. So there's more different types of cases that actually have different distributions. So maybe you have to branch out and have different kind of statistical distributions aligned or simulated based on the properties of a case, for example.
Yes. And as I said, when you're trying to match the output, you're really trying to match the distributions. Mm-hmm. And trying to match, distribution has many, many different moments, right? So the more fine-grained you want the match, the harder it becomes.
Yes.
So that's why we typically stop at the, standard deviation and the mean. Mm-hmm. Because, I think that so far has been good enough to build a wind tunnel that you can then use to do your what-if analysis.
Right. Yeah, that's really the question. Where do you stop, right? You could build the whole world into the model, but so finding the right place to stop is exactly where you're getting to reproduce reality as closely as possible. So this would be kind of the result of the tuning. Yeah, so I remember when we were doing simulation at the university. So for example, one thing we saw is a very simple one that everyone who's working with processes will understand, is that if you're going through the loop, you can have like a simple branching probability, like how likely are you going to go ahead or to go through this loop. Mm-hmm. But if you have done this once, for the same case, actually, usually you're less likely the next time, once you have gone through this loop once, to go through it once more, right? So there's fewer cases that go through the loop twice or 3 times or 4 times. So that's, I think, one example where a simple model would maybe have just the branching probability in this one decision place. But if that influences a lot, you might actually put some more logic in there and distinguish further.
Yes. So it is, as I said, you start with a simple model, and then as you may need, you stratify it further.
Right. Yeah. Okay, great. So thank you for those insights. Another thing I wanted to talk about is that, and it's really nice specifically today where you presented two cases. So you had this one case making use of both simulation and process mining, and then in the second case purely deriving process improvement insights from process mining alone. So where do you think simulation can really add a lot, where you would just by process mining and by deriving estimates from the likely improvements that you can expect just from the process mining analysis itself is not enough, but where you need kind of the tuning possibilities then of these alternative what if scenarios in the simulation model? Are there specific domains or specific process questions where you think?
So I think that's a very good question, because the way at least the way I have used process mining and simulation. In process mining, I typically use a lot to get insights into what's going on, right? So the discovery part. When it comes to saying, okay, I see this problem, here's a bottleneck or something, it's just using process mining, it's very hard to say what change do I need to make and what will be the quantitative impact of the change. Mm-hmm. I may see a bottleneck, so we may say, okay, we may need to add resources here. But how much resources do I need to add? Yeah. And do I need to bring in new resources, or should I just share resources between something else and reapply that to this bottleneck, the scheduling policy or something like that? Yeah. What is the right impact, and what will be the quantitative impact? If I did add resources, would it take away the bottleneck entirely, or would it just improve it by 10%? So to get those kinds of insights, those quantitative insights on what will be the impact of the changes on the new process, that's where I think simulation becomes at least quite essential in many cases. If it's a problem about something like work is flowing through a certain step, and we are seeing a lot of stuff going through a path which we don't want it to go through, those are things that you don't need simulation for. You might just say, hey, this is something shouldn't happen. I need to train my people so that they do things a little bit differently so that they can improve the process. But when you start getting into more quantitative estimates of what will be the impact of changes on queuing, on turnaround time, on utilization, things of that nature, then I think simulation becomes very helpful. But they are really complementary, right? I mean, you kind of go back and forth between process mining and simulation, as I described in this example. So you start with process mining, you go to simulation, then you come back to process mining, and you can kind of iteratively use that to get to the improved and optimized solution.
Right. Yeah, exactly. I completely agree. And I like the example that you gave. So, for example, if you have a path in the process, maybe where you're doing like a rework step or an unnecessary step that shouldn't be there, it's relatively straightforward to, for example, filter your data set in the process mining tool and to filter on those cases that don't go through this unnecessary step and use kind of the timing on the performance measurements from those good cases, if you will, to as kind of an estimate, like, look, this is what we could be doing if we wouldn't do this one thing that we don't like. So that's maybe a situation where you wouldn't necessarily need process mining, but once you're looking into, again, more the human behavior or some kind of resource planning, scheduling, or having more resources available than now, so then it becomes really complex to do these kind of estimates, and this is where simulation can really help by modeling those scenarios out in more detail. Right?
Yes. Yeah.
Okay, great. Well, we're running a little long, but I have one last question I want to ask as well. It's like, I'm curious what you think about that, because what we see is, like you mentioned in the beginning, you're applying all kinds of different statistics, like simple descriptive statistics can already sometimes yield a lot of answers.
Yes.
And then, predictive analytics is something that, of course, people are also in the past years more and more are interested in. And what you realize sometimes is that to be able to do predictions well, you actually have to have a certain kind of stability in the process as a baseline to be able to do predictions that really work out and are reliable. I'm curious, do you think there's also any kind of prerequisites or something that's necessary to be able to do simulation? So are there processes where you think simulation cannot be used because, a certain prerequisite doesn't apply?
Yeah. So when you build a simulation model, again, my focus is make it as data-driven as possible, right? So if you run into a situation, which we do run into occasionally, is when you just don't have the data, right? And when you have to make all kinds of assumptions, you start making assumptions on what's the time. And if you've gone through any kind of simulation conferences or any places, when people don't have any data, typically they'll use a triangular distribution, right? What's the min, max, and the mode, and they'll work with that. I have found that in complex business processes, if you start making those kinds of assumptions in your simulation model, then the model is not as useful. And in those cases, it's not a good use of simulation tool. You can't use it for predictive purposes, right? For predicting what will be the impact of changes and things like that. Especially in the service world, and in particular, because in the service world, a lot of the distributions, when you look at the real data, as you can see even here, I know there are icons, is that there are tails on these distributions. So if you try to approximate these tail distributions, sometimes even long tail distributions with triangular distributions, the results can be way off. And you won't know, what's really causing the model, and then all this tuning and everything goes out of the window. So I think in those environments, and I think that is why the data-driven approach. So if the process is very stable and very tightly controlled, then yes, you can even with assumptions you can get a lot out of the model. But if the process is there are a lot of human factors involved, a lot of variability involved, like with these tail distributions and things like that. Then you need to have good data. So it's what is the right place where the model is very useful versus less useful. It's hard to say, but there is some point where you have to know how stable, as if you want to call it, how stable is the process. More stable it is, yes, you can get a lot of the simulation with simpler data sets. But the more variability that you have, and then you need some of this entire data-driven approach that I discussed. It's almost essential. Otherwise, you will not be able to get good improvement solutions.
Right. Okay, great. I think that's a great place to stop for today, but we're not going to stop talking about this topic. So everyone, please, come to the AIG channel in the Campfire community. Ask your question. Share your own experiences. Have you worked with simulation in the past? How were you doing it? Which issues did you encounter? How did you do the tuning of your model? We are curious to hear about it, and Sudhendu will be around as well. And tomorrow we will be back at the same time as today, and we will start by addressing some of these discussions and questions and wrapping everything up. Thanks so much, Sudhendu, for today, and I look forward to seeing all of you again tomorrow. Bye-bye. Welcome back, everyone. Welcome to today's fourth session of this year's Process Mining Camp. And we will, as in the past days, we will start again with our daily Process Mining Cafe, where we welcome back the speaker from the previous day to talk some more about what was discussed in the community in our Campfire Slack about their presentation. And so welcome back, Sudhendu, from yesterday's talk. Hi, Sudhendu.
Hi, Anne.
Great to have you back again. Let's jump in right into the discussion, because there was quite some conversations going on in our Slack channel after your presentation yesterday. And one thing that I thought became clear is that a lot of people are interested in process mining, in simulation. And there are some who have applied it also in the past. For example, Marcos mentioned that he has applied simulation at a telecom company in a recall process. But for example, David was a little bit skeptical if it's really useful for human processes. So overall, it seems it's more used in production and manufacturing environments rather than service processes. Would this also be your impression at this point?
So, thanks, Anne. First, before I answer this question, I really appreciate all the comments that people made, and in particularly, the cartoon that was put together, that was very well done. I just saw it, so thank you, everyone. And then going back to your question, Anne, so yes, I mean, simulation, a lot of the success stories you hear about, and as you had mentioned, I think the simulation is a technology that predates process mining by perhaps a couple of decades, came from manufacturing, where things were a little more controlled. Some of the processing time distribution, some of the other things, especially the more automated a system is well defined, and then a lot of emphasis there was placed on understanding the impact of failures and Markovian sort of mathematics and stuff like that, right? I mean, from a manufacturing systems engineering standpoint. When you come to the services world, again, if you ask me, can we model human behavior generically through the simulation tools? I mean, the answer is probably no. I mean, it's very, very hard. But when I gave the example yesterday of the processes, they are fairly well-structured processes. I mean, there is a human behavioral component. I mentioned, for example, the break, people taking slightly extra breaks, longer breaks on less busy days and things like that. They are sort of an overlay on a fairly well-structured process. So instead of machines doing things, people are picking up envelopes, opening envelopes, moving things to the scanner, indexing. Of course, there is variability, which we capture through the distributions. And so I think when you have such an environment, simulation can be quite useful. And there is certainly more variability than, let's say, a totally automated system where the variability shifts more to failures when machines just break down for long time. But here it's more about, certain tasks taking longer. So when we are looking at... Sorry about that.
No problem.
So my point was that if you look at the class of problems you are tackling with simulation and the excessive amounts of data that have now started becoming available, which did not exist, let's say a decade ago, I think you can make a lot of progress with simulation. Again, these are not answers that you can make you can't make generic answers. You might still run into situations where there is a lot of gap in the data, there is too much uncertainty about the behavioral aspect, and you'll have to kind of take it based on what the situation demands. I hope that answers the question.
Right. Yeah. So what becomes clear is that these are not like knowledge work processes where a lot of creativity is involved or people do things differently every time, but it's almost kind of a production-like process involving people where this technology becomes applicable in the service industry.
Yes.
Right.
Yes.
So people were really also curious about learning some of the more details. So for example, Sean was asking what type of simulation model you were creating. Thomas wanted to know what software you were using. Marcus was asking about what exactly you were configuring in the model. For example, resources, the flow, process flow, what were the parameters? Maybe you could elaborate a little bit more on these aspects?
Yes, sure. So the tool that we are using here, I mean, we have used other tools before, but currently we're using a software called AnyLogic. Now, AnyLogic is discrete, it's actually a simulation modeling software. And when I say it's a simulation software, it's really a programming environment, right? It's a visual programming environment where you drag blocks, you connect them. But fundamentally, what you're doing is you're doing programming. And one of the things we like about that is this particular product is, there is a Java interface where you can actually add code snippets to different aspects of the model to capture, maybe some complexity it's harder to model just with the existing blocks. And it also has other, and primarily we use the discrete event simulation framework. It also has other, the same software environment, AnyLogic has other modeling frameworks. In simulation, you also have System dynamics is another way of building simulation models. I think it's a little harder for our kind of space. The other domain is agent-based. So all three capabilities of building simulation models available in the software, which is why we actually picked it. And so that's the domain. Now, the other question about what were we configuring to get the improvements. So in this example that I talked about, and again, I must repeat, this is specifically for what I covered yesterday, was if you look at it, there was a manual physical aspect to the process where mail was coming in, people were opening up mails, sorting, prepping, and then taking it to the scanner and scanning it. And then after that, it became a digitized workflow from that point onwards. So there were several things that were going on. I mean, one was we configured, for example, the mail that comes in. We even actually worked with the mail drop to move the time in which the mail was getting dropped. So it was getting dropped at several times during the day. So one of the things we worked with them was to change that. We changed, so earlier it was like all the operators were coming in at a certain time in the morning. We staggered some of them to balance the flow, the way the work was moving through the operation. We also changed the number of people who were working in, let's say, the different departments. So it was the same group, but what would happen, for example, let's say there are 10 people, and the mail comes in, and there are mail tubs, there are stuff that's coming in these envelopes, the overnight packages. And so let's say 6 out of the 10 go there and they start opening up envelopes, working with the tubs, sorting things, grouping things and whatnot. We changed those numbers. So maybe if it was 6 before, our model said you should only put 4 there or things like that. So that was another parameter we changed. We also changed, for example, the batch size. When I say batch size, if let's say a mail comes in and let's say a tub has 500 mail pieces, you might want to sort all 500 first, group them into whatever number of bins you have, and then you might take it to the next step in the process. We may have changed the process and said, don't do 500, maybe do 200, and then once you have created the bins, move it downstream and then work on the remaining 300, right? So basically splitting these bigger batch work into smaller batches. Then we also changed the process batch. So when I say process batch, let's say you open up the envelopes and then you are putting it, preparing it for scanning, right? And you may have a certain batch size that you may want to, so we played around with that and found what was the optimal batch size. Optimal in the sense is something that gave us significant improvement in the flow without wasting people's time, right? So I think those were some of the changes that we made. We definitely focused, I believe, also on some of the skills of people. So we may have moved some people who are doing certain tasks to do other tasks as well, right? So there were 4 or 5 different tasks, as I mentioned, right? There was the paper sorting, mail logging, prepping, scanning, and indexing. And we moved some of the people around and had other people do what they were not doing earlier. So equivalent of cross-training, right? So those were some of the things that we did here on this, the first part of the process, improvement. Mm-hmm. Does that answer?
Yes, I think that gives a good overview. It's like Jeff was also wondering whether you adjusted prioritizations, for example, in the pull basket. I know that was one of the things you were doing last year in the study you presented last year, but was this also relevant this year?
So yes, in the study that I presented last year, that was one of the primary drivers of the improvements that we got because of the here on the upstream part. I mean, if you look at the work that comes in, once it gets prepped up and gets it's rather similar. Only the overnight part had had to be processed a little bit differently. So I don't think we changed the priority in which the work was getting done, but I did say that we did change the time when the mail was getting let's say, delivered. The first batch of mail was getting delivered, and how many people were coming in, maybe slightly staggered compared to the other teams. So if you want to call that, prioritization, that was the level of prioritization, but not necessarily in terms of take this kind of envelope and prioritize it over that other kind of envelope, because when stuff comes in, it's kind of hard to determine the complexity. You only get more information about the complexity of the task once you have gone through, I would say, the indexing process, when you have more awareness of the content of what the customer is requesting. So no, not on the front end part. We did not change any of the prioritization in this case.
Mm-hmm. Okay, great. Yes, thank you. So another question that I thought it's good to bring up, as it connects also to one thing that we already discussed a little bit yesterday, is so Johan was asking about basically the stability of the processes and the sub-processes, right? So that, and we talked a little bit about that. Needs to be a certain stability in the processes to be able to use simulation for a particular process. And so maybe you can talk a little bit more about that.
Yeah, when you say, when you say stability, I'm when you look in a production environment, right? Typically, failure is a big component. Failure in the sense that when machines go down, they go down for a significant amount of time, and they could just halt the entire production flow, and that has a big impact on how you design capacity and stuff. So there, the notion of, I'm thinking about failure as one kind of component of stability. You do have that even in human operations. People do fall sick and could be absent and things like that. But what typically happens is the impact is not as severe here, because either there are other people who can pick up the task. People can extend their work hours to meet those requirements versus an environment where there's one machine and it fails, and then everything shuts down. So there there's a different kind of dynamics going on in those environments. Now, when you're talking about the stability, the other form of stability I'm kind of contemplating here is the mix of the work that arrives. Would that be? I'm trying to understand what he means by the stability of the process in this type of environment.
Right. Well, I think it's in general and can relate to different parameters. So probably all of the parameters that you're trying to model or to include in your model, you have to have a sense of how reliable or how stable they are, how well you are capturing them through the distribution. So he mentioned, for example, let me see, he was talking about run charts, which are similar to control charts, right? And there's, of course, you were talking about the distributions, that not everything is normally distributed, but that you might have these kind of tail heavy distributions. So are there certain, maybe as a general rule of thumb, are there things that you're looking for when you're determining these kind of factors?
Yes. So he's right. So if you have a distribution, and as the tail grows, basically the variance is growing, right? Or standard deviation is increasing. So variability is growing as the tail keeps growing. And the more you have, if it gets really heavy tail, which would be the extreme case of variability, then clearly, it creates a different quote-unquote problem set with the simulation, right? Because now you're dealing with, you have to make sure that even is the output of the simulation stable, or even the mean that you're talking about, is that starting to fluctuate, which means that, and basically the way you would deal with that is you need more and more and more and more data, right, to get closer and closer to accuracy, and sometimes there may be even quote-unquote instability in the results. I don't think we see that in this type of an environment. So, but it's definitely a good point, and there has been work done in this area when people have looked at those extreme cases of variability and what it does to the simulation output and things like that. I mean, it's a longer conversation, but I think in the environment we are dealing with, when I say heavy tail, what I want people to realize is that just looking at the mean is not sufficient. And sometimes if you just focus on improving the mean, you may actually worsen the tail behavior, right? So you have to keep into account both the aspects, because the tail behavior impacts the most disgruntled customers actually come from the tail. I mean, people who are expecting things to be turned around in 1 day, if they get it in 5 days, they'll be quite upset. So the tail behavior has very big ramification on how customers perceive. So, but those are good questions. Again, you have to be aware of them. When you see the tail grow, there are other strategies that might work. Again, scheduling. There's a plethora of scheduling approaches that people could use, and as the variability grows, you have to start looking for, how do you address more and more of that tail behavior. I mean, I'll leave it at that, because it's a long conversation on how we would address those types of situations.
Right. So something to follow up on, and to maybe have more concrete discussions around. I think that's a very good point. Yeah. All right. So I think there's one more point, not directly related to simulation, but related to your first case that I wanted to bring up, because what you mentioned, that in the first case, from the two cases that you discussed yesterday, you had a mix of digital and manual data, right? So for a part of the first process, you had to actually collect some data manually. And you mentioned that, this is something that people do and have done in the past through time and motion studies. And I also encourage people, if they're in the situation that they don't have any data at all for a particular process that they really want to analyze, or maybe if at a certain time they realize they have a blind spot in one of their process areas that they really need to get more visibility into, but there is no data because it's the manual part of the process, that you can actually, not maybe that much data, but you can collect data for a certain period of time to gain some visibility into this, right? So I think it's something that people in the process mining area who are in this unfortunate situation, of course, if you have good data, that's always much better, but sometimes, collecting some data is the only thing you can do. So are there some maybe standard methods or references or something that you can recommend for if you're in the situation to have to do this?
So what we have found that has worked for us, so if it's a computer-based processes, I mean, we have actually just done a lot of WebEx recordings of how people are working, right? And then basically annotating that and trying to see, how much time is being spent where, and, maybe do it a few times if you want to get some idea of a distribution. As I said, you have to understand, how much data do you need will depend on how much variability there is in the process. So that's one thing. If it's a physical process, like in this case, the one that I talked about yesterday, when operators are actually opening up envelopes, I mean, we just video recorded them, right? So we did a video recording, and then from those video recordings, we were able to kind of come up with estimates of, how much time it takes to do the prepping, and how much time does it take to do the sorting and things like that. So yeah, I mean, on a computer-based process, I said, even simple WebEx recordings of people can be very helpful. And if you're doing this on physical processes, these days it's pretty easy. You can even just use your phone and record people doing the task, and then create a few samples, and then from there you can draw some conclusions. Right.
Okay, great. That's all the time we have today for this Process Mining Cafe. Thanks so much for coming back, Sudhendu. We will talk some more, and please continue the discussion in our Slack community also about this topic. But for now, thanks, Sudhendu, for being there yesterday and today. And we are going into a quick break, and we will be back quarter to the hour with our practice talk for today.